Hello, and welcome to Penrose From Scratch, um, which is hopefully going to be a bit of a mini series. I've no idea how long this is going to take. Depends on what we end up wanting to implement in our From Scratch. But this is going to be a look at writing your own X-level window manager from scratch. Pretty much from scratch. We're going to base it on top of a library I wrote called Penrose. Penrose is the kind of back end and kind of plumbing kind of layer to let you kind of do this kind of stuff in a bit of a nicer way. It borrows very heavily from Xmonad, if you've ever used Xmonad, in terms of the design. But all that is kind of stuff we can get into later on. And if you want to kind of read ahead, I've got some links and sort of docs that I can kind of show you, which kind of explain bits and pieces. But we'll kind of dig into stuff. We'll have a look at how things work. I've had various bits of feedback from people that the kind of skill ceiling for Penrose is pretty high. I think that's probably fair. It's aiming to be a library for programmers as opposed to a window manager that you configure. It's probably the best way of putting it. So yeah, you kind of need to write the program logic yourself. I've got a bunch of it written for you. There's various bits and pieces. I'm adding more to it all the time. But yeah, it's not much comes out of the box, which is kind of what we're going to see. We're going to start with what comes out of the box as the bare minimal example, and then we'll build from there, which is kind of cool. So I suppose first things first, what is Penrose? If you go have a look at it on GitHub, it's sminnes/Penrose. Like it says, it's a tiling window manager library. Kind of does what it says on the tin. If you don't know what a tiling window manager is, you're kind of looking at one. This is kind of what you get from a tiling window manager. You kind of get, when you open programs, they kind of position themselves automatically for you. It's all about kind of minimalism and efficiency and that kind of stuff. Some people really like it to look kind of super fancy. I kind of don't care. I spend my entire life in the terminal. I'm a professional software engineer. And yeah, even at work, I kind of get lots of people kind of saying, why aren't you using an IDE? I'm not using an IDE. I'm using Cocoon because there's an ASCII art cat, and everyone wants an ASCII art cat. And yeah, so I kind of live in a terminal, do lots of stuff with Tmux, and maybe a web browser, and that's kind of it. But with all that said, you can do quite a lot of fun things with a tiling window manager, and it seemed like a fun hobby project to kind of get me through lockdown and COVID. I needed something to do. This seemed like a good idea at the time. There we go. So there is a TLDR. I tend to ramble a bit, so I will try and kind of summarize every now and then. TLDR is pretty much, there's a getting started guide. You can go to the link here, and it will literally talk you through the whole thing. It'll talk you how to set up Rust. It will talk you how to set up the repo and get a very minimal layer set up and ready to work. That's kind of going to be episode 1. That's kind of what we're looking at right now. And once we've got that in place, we've got a starting point that we can play around with and add functionality to. So what you're looking at the moment is my personal setup. That's also available. If you go to sminnes/mypenroseconfig, you can kind of read ahead and see what I'm doing there. Nothing super fancy. Anything kind of particularly cool and useful, I tried to factor back out and put into the Penrose crate itself, so it's available for people. There's a couple of custom things in here, that kind of stuff that we can look at later. So yeah, those are kind of your main resources. Go to GitHub. There's an issue tracker. There's a bunch of stuff in there that is worthwhile having a look at in terms of closed issues. And stuff that you'd want to kind of have a look at to see if anyone's going to hit the same kind of problems as you before, or ask the same kind of questions, that kind of stuff. My personal config's there for cribbing. There's a whole bunch of user-facing docs that kind of explain how stuff works. And then there's the kind of official documentation that you can get to from crates.io, which is kind of the Rust kind of version of NPM. I suppose if you've ever done stuff with JavaScript, it's kind of where you can go find and download libraries. Which we'll have a look at just now. I suppose we should probably get started. So, if we're going to work from scratch, we need a code base. That's probably the best place to start. You need Rust. installed on your system. If you haven't got Rust on your system, rustlang.org, get started. We'll kind of talk you through how to get that installed. Make sure you've got that set up first. So pause, get that done, make sure you've got Rust, then you're good to go. And you need your text editor of choice. I'm not going to go through kind of developer setup and all that kind of thing. There's plenty of videos online to sort of show you how to do that. So pick your editor of choice, your IDE, whatever you want to use, and we're off to the races. So as you can see from my shell history, I'm cheating a bit. It's not entirely from scratch. I've got a couple of bits and pieces that I've already set up so that this isn't me just blindly rambling along with things. If we create a new project and have a look, you don't get too much out of the box. You get hello world, which is always nice, and you get what's called a cargo toml, which is, if you've worked with JavaScript kind of stuff before, it's kind of like package JSON. It's kind of where your dependencies are specified, where kind of your build config is, all that kind of stuff. We're going to chop and change a few different things to kind of get this working, and you'll see how that works as we kind of get into it. First thing is we're just going to check that our local environment is working. So if we do cargo run, that will run that main RS. If you remember, main RS was hello world, and that was literally it. And we get hello world. So Rust is working on our system. We've got a starting point, so that's great. I am going to shamelessly steal something that I previously set up, because there's a couple of different ways to specify dependencies, and I wanted to make sure that we had a good way of doing it. So we're going to do this. All this I'll put into our repository at the end, and link will be in the description. So if you want to kind of skip ahead and read through what's in Git, you can see that. But we're going to set up a couple of pieces to help us just have a bit of a nicer experience of running the program. And as and when things go bang, and things will go bang because we're writing software, software always goes bang, it's useful to know why. So anyhow is a fantastic library for doing error handling. Makes things way, way simpler than it would be otherwise. Cuts out a lot of the verbosity. It's really quite nice. And then tracing is a really nice way of doing really nice logging. Logging is good. You want logging. You should log inside of the code that you write and add to your window manager. It's very helpful because, like as I said, when things go bang, you kind of want to know why they went bang. After that, we need to pull in Penrose. So there's a couple of ways of doing that. The way we're going to do it just now is to pull directly from Git. Actually, maybe we're not, because my internet connection is a bit useless at the moment, and that wasn't working. So we'll see. We'll try and do that. This means that we get whatever's on the head of develop, so you get all the latest changes. If I'm making any edits to Penrose and not pushing new versions live while this video series is ongoing, you'll be able to track along by following along with what's in Git. If you want to take the kind of safer route and take only stable code, just specifying a version number is a way of getting whatever the latest version inside of crates.io is. Current latest version as of right now is 0.3.2. And we're not going to use it this episode, but we'll bring along Penrose UI as well. That's what's driving this little status bar up at the top. Super minimal, but it's nice to have. The other thing, which you'll see if you look in my config, is to do this, and that lets you use a local checkout of the repo and just load the code from disk rather than cloning the repo or pulling it down as a tarball from crates.io. I tend to do that so that I can make local changes with my local setup and make sure that's all working fine before I push it out to Git and GitHub, but it's up to you. If you want to have local checkout and hack around on things, that's a way of doing it. So we can do that. That's great. That gives us our dependencies, so we're kind of good to start. But then we have a slight problem, which is that this says hello world, and that's not really going to be helpful for managing Windows. So thankfully, in true Blue Peter fashion, here's one I made earlier. So if you go to the examples directory in GitHub for Penrose, and if my internet will actually load, there's a couple of different examples available for how this stuff all works. And what we're going to start with is minimal. So minimal is kind of what it says on the tin. It's not got that much to it. It really is about as minimal as you would want to go. A lot more minimal than what you're seeing on the screen just now. That's me with a lot more config on top of it. So we'll copy that out of GitHub. We'll shamelessly paste, as is the way, and get rid of Hello World. Hello World's gone. Dead to us now. But here's Penrose, or rather a minimal Penrose config. We kind of don't need that little helper up at the top. We do have Penrose from scratch, so why not? And so what we're doing here is we're pulling in a variety of pieces from Penrose itself. You'll see there's a whole bunch of imports from Penrose, a bunch of use statements. And I won't go into a huge amount of detail about what all this is right now. That's kind of the point of this video series, is to kind of dig into that stuff as we go. But you'll see that the code base is kind of broken up into different pieces. There's the core, there's built-in functionality that is kind of user-facing stuff, but isn't like the core window manager itself. There's also some stuff called extensions, and then there's various kind of backends and things that you can kind of plug in and work with. We're also going to need some hash maps for building out our key map, and we're also going to bring in tracing subscriber for getting those logs set up. This is the kind of default bindings for getting things set up and running. It's fairly kind of self-explanatory if you've used a tiling window manager before. This should be kind of pretty much what you've had if you've used something like DWM or Xmonad out of the box, maybe i3. But the behavior in i3 is sort of manual tiler rather than kind of preset tiling algorithms, so it will feel a little bit different. And then we're going to set up 9 workspaces. Same kind of idea as DWM and Xmonad. That's what you're seeing along the top up here. And then that's pretty much it. So this is your key bindings. If you're ever lost about what to do, you open and back up your main RS, you have a look at your key bindings. That's what we're running. And then our main function is super simple. We set up something that's called a tracing subscriber. That's basically the thing that's going to handle our logs for us. We kind of say, hey, cool, this code's going to be logging. I'd like you to grab onto all of that and print it out for us. This is kind of cool. It lets you kind of decide how you want to do that. So if you want kind of pretty printed stuff with colors, you can get that. If you want it as JSON so that you can kind of parse the JSON and kind of do fancy things with your log file, you can do that. There's a lot of bells and whistles you can go and tinker with. It's well worth looking at that if you want to do anything fancy with that. We set up something that we call an X connection. So that's actually talking to the X11 server. And that's the thing that does the heavy lifting, actually moves your windows around and makes all the magic happen. We're then going to parse the key binding map that we've just defined above and set up the window manager with default config. We're not going to change anything. So it will be out of the box, brand new, pretty much as, well, not pretty much, exactly as the defaults will give you. And then you call window manager.run and you leave it to it. It's an infinite loop. We'll kind of get into the kind of program structure in one of the future episodes. One thing that you might be surprised about is we have a test. I highly encourage you to write tests for the code you add into your window manager. Speaking from experience, it's annoying as all hell when you think you've implemented a cool new feature and you recompile and you restart your window manager and your window manager crashes. Because getting out of that state can be a pain. So test your stuff. We'll go through how to do that as we go. This one is super simple. What this is doing is making sure that when we try and parse our key bindings so that we can actually use them with the system, that parse of the map that we've defined up here works, so that we haven't got kind of garbage in here and that all breaks. So if the internet connection gods are with me, which they might not be, we'll try doing our cargo test and we'll see. Good, it's just compiling. We don't need to bring in anything else over the networks, that's fine. One thing you'll notice with Rust, if you haven't used it before, is initial build times are slow. That's just a thing. I know this painfully well. I work with Rust for my day job, which is great. I'm really happy I get to work with Rust for my day job. But me and my team have also put a heck of a lot of time into making sure that our continuous build system is as fast as we can make it. And even then, our build time is like 10-15 minutes to rebuild all the different servers that we write and all that kind of stuff, which is really annoying. I'd really like it to be faster than that. I think compared to other teams in the company, people think I'm being ridiculous when I complain about 15 minutes being too slow, but it shouldn't take 15 minutes. Thankfully, Rust has something called incremental compile, which means that first time round, it does all the heavy lifting for you, and after that, it will compile what you've changed, and it's a lot faster. So if you have a look there, we've now finished, we've run our one test, and our result was okay. We can successfully parse the bindings, which is good. And if we do cargo test again, it's a lot faster. Still a little bit slower than you might expect from just bare C, for example, but that's because that's what the Rust compiler is doing. It's doing a heck of a lot of stuff around various bits and pieces of checks and optimizations and things it does. I won't argue that it's fast, definitely not, but it is pretty cool and pretty helpful. So we've got our main RS. It's got some key bindings. You probably want to change that out for the name of the terminal that you've got so that you can actually open the terminal. And I use dmenu run is the example I've got here. What I actually use day to day is something called Rofi or Rofi. I never know how to pronounce it. But either or, you want a program launcher, or at least something where you can open a terminal and then run commands. At that point, we have a window manager. That binary is a window manager. If I do cargo builds, then rather than just running our tests, we'll actually compile our main RS. And if we go to target debug, you'll see that there is Penrose From Scratch. That's our window manager. We made a window manager, guys. It's fantastic. The only problem is you need to run your window manager. And getting that set up can be a bit of a pain. So the last thing we're going to do for this first video is show you how to set that up, and then we'll be good to go. And then next time round, we'll be running from inside Penrose From Scratch, and I'll show you how we can get kind of recompile and restart all hooked up so that you can kind of then just sit and hack on your window manager from inside your window manager. But there's a little bit of a bootstrapping process to kind of get that going, which is a little bit unfortunate, but that's okay. So there are a couple of things that we need to sort out to get this to work. First off is I'm going to shamelessly copy some more stuff over from my previous attempt at this, and I'll show you what they are. I'll just get the copying done first, and then we'll explain what's going on. So, if we look in bin, there's a couple of things in here. So there's Rofi apps, which is this nicer launcher. We're not going to set that up straight away, but we'll move that over to that in a second. There's floating webcam, which is this. Hey. I was trying to point on the screen to the video. That's not really going to work. That's a super hacky little script using MPV. To literally just connect my ThinkPad's webcam to MPV and dump it out. And it works. There's then some stuff that I've got to make that float up into the top corner. We'll set that up so that we can get that working. And then there's something here called Run Penrose. And what that is a little wrapper that I like to use around Penrose. So this is just an infinite loop that starts Penrose and redirects its log out to a file, and then any time that Penrose dies, if it crashed rather than exiting cleanly, it will copy the log from the instance that just crashed out to prev Penrose log so that I can have a look at what happened. Otherwise, it'll leave the log where it is, it'll start overwriting it, and then it will restart Penrose and off we go. And then there is a helper that I have as a key binding to kill this script so I can actually close the window manager. But what this lets me do is recompile Penrose, kill it, start it back up again using the newly compiled version, and you can kind of iterate on your window manager that way. It works quite well. We also have some scripts, and one of those is a way for just unlocking your SSH keychain. That is very useful if you want to actually use SSH keys for pushing changes to Git, or GitHub rather. That took me a while to sort out, and when I finally got that working, I was very happy. And then I've also got Penrose Startup, which is something that we'll set up next session, hooking into this. This is just doing a bunch of setup stuff. So when the window manager first starts, we can set up external monitors, we can turn on a compositor, we can make sure that we've got networking and USB management and volume and notifications and all that good stuff. We kind of need to bootstrap that somehow. You could write all that in Rust. I've got this shell script I've carried around for years from different places and kind of hacked on under different window managers, and it's kind of nice just to run the shell script, and it just works. So we got that. The other thing we've got in here is penrose.desktop. We're going to pop this into user share X sessions. Oops. And if we pop it in there from your login screen, from your, what's that called again? Light DM's the one I use. I always forget the name of it. Display Manager. You can select Penrose as your desktop environment natively. So this is super dumb and simple. It literally is just call that run Penrose script. That's it. So it starts that infinite loop, Penrose runs, profit. And then the last thing we've got in here is a makefile. And this makefile is going to be how we quickly set stuff up and copy everything across. So Penrose from scratch. I knew I'd forgotten to do that. Cool. Oops, if I can type. Like I said, we're programming, things will go wrong. Oops. And from scratch. Cool. And this lets us do make build. I'm just going to build in release mode, so that's going to be optimized version of the binary, be a little bit faster, a lot faster sometimes, and hopefully a bit smaller as well. Doesn't really matter too much, but we don't want to have a massive binary floating around if we don't have to. This will then do that first time compile again. So again, first time will be a bit slower. It will be faster once you get into recompile. This will give us the version of our window manager we're actually going to run. And then once we've done that, we are going to run make install, or sudo make install rather, because we need to copy stuff to a place that only sudo has access. And I highly encourage you to read this makefile before you run sudo make install. Never run sudo stuff without knowing what you're doing, because it can do arbitrary things to your computer. What this is doing is copying the binary that we've just built and those helper scripts out into your user local bin. We're also setting up user local scripts so we can get at a few things from inside of Penrose itself, just so they're in a known place that we can get access to. And that's pretty much it. It's copying stuff across. There's also uninstall to rip all that stuff out after. But this is what we'll run each time we've edited stuff. So the usual thing we'll get is make build and sudo make install is what we're going to see. We need to wait for our compile to finish, but once that's done, we'll be able to run that and get it all set up. So bits for you guys to do at home, if you're following along, is copy that user share X sessions file across. You need that in there. You might need to be sudo for that. I forget if you need to be sudo to copy that in there. double check. We need to get our main RS set up, and then we're going to do make build and sudo make install. And that will copy across our binary. So this is our make build. It's now done. And we're done. And from this point, we can log out and then select Penrose as our desktop environment. And then we can start hacking. And I will see you in the next video from that.